Welcome to EDU World Space.
Let's find the values of x for which this series converges, and for these values of x, we'll actually go ahead and find the sum as well. So let's break this into two parts. First, we just want to know the x values for which it converges. So let's call that part 1, and part 2 is over here when we find the sum.
Here's a clean
So let's just
professionally
rewrite
formatted
this
presentation
series.
of the calculation shown in the image.
This is actually a geometric series, maybe in disguise the way
Application
that
of
it's
the work
written right
energy
now.
theorem, wet. From the
I'll
work
just
energy
pull out
theorem,
that
the
3
force F is given by F
and
equals
then
frac
put the
text
n on the
KE,
outside of the
where
parentheses.
KE equals kinetic
So we have
energy,
geometric,
S equals stopping distance.
and we see
When
that
given for
r
object
equals
A,
x
FA
minus
equals
2
frac
over 3.
100,000, 0.10.
And we know that
For object B,
geometrics
FB equals
only
frac
converge
225,
when
1500 equals 0.15 text
the
spacing.
absolute
And
value of
force
r
ratio frac FA, FB equal frac
is less than
0.10,
1.
0.15 equal frac
So
2
we
will
need
result.
the
The box
absolute
frac
value of
FA,
r, which in our
FB.
case,
Would you like a PDF version
absolute
of
value
this
of x minus
explanation?
2 over 3. We simplify that a little bit. We need that to be less than 1 due to this over here. So solve this for x. So first multiply the 3 over. And then using the definition of the absolute value, this means that x minus 2 satisfies this. And then add the 2 to all sides of the inequality. So in this case, all 3 sides. And we have our interval for x. So these are the x values for part 1 for which the series will converge. And we get this from using the fact that the series is geometric. And we know geometric only converges when the absolute value of r is less than 1. All right, so that's enough for part 1. Now for part 2. Geometric series. We know the sum will equal the first term of the series. This is always the formula. The nice thing about this formula here, the way that it's written, is it doesn't depend on what the starting point is. So here, we just go to the first term by plugging in the smallest n that we see. In this case, it's 0. So you have x minus 2 to the 0 power over 1 minus r. In this case, we know what r is. That's just x minus 2 over 3. So we have, let me come down here. We have 1 up top. And then 1, let's go ahead and get that common denominator. 3 minus x minus 2. But in the denominator, I have another 3 down there. So let me put that 3 on the top. And then let's go ahead and simplify. We have 3 and then plus 2, which is 5. And then minus x. So for the answer for part 2, again, we're only assuming that we're only looking at these x values between -1 and 5. So assuming x is in there, then the value of this summation that we were supposed to evaluate is equal to 3 over 5 minus x. And that's our final answer.